This is the exception handling example from the slides. Again, there was a function defined that is called this fails, where we're simply returning 1 divided by 0. This is not defined, so this would result in a runtime error that Python will produce. We put this in a try except block where we're trying to call a function that might fail. In this case, it's guaranteed to fail. And we are catching the 0 division error as an error here, and then we're just giving a message to the user that something went wrong. And in the end, we can still say print, but this will execute. Okay. So if we run this, you can see that obviously this fails. We are catching it, but we are making it through this piece in the code. If we comment this out, all of it, we're just calling a function that might fail, we're getting a 0 division error and we don't make it to something down here. The use of this is that in many cases, you might be able to ignore bad results, and instead of having an ungraceful ending of your program, you can handle the error and either tell the user what is going on and you can't move on any further, or just ignore or otherwise treat the error, perhaps ask the user for additional input if the input was wrong. So this makes sense to do in some cases, and this will execute here. We can also, if you don't know what errors you want to catch, you can go very broad and just catch all of the exceptions as one. I will warn you, this is not considered good practice because you don't know what the exception really is. By a 0 division error, you might react differently than if you get a string as a return value and you expected another type. But overall, 0 division. But overall, it is a good practice to kind of isolate code that might fail with this exception handling procedures so that you know when things are going wrong and you can deal with it.